All right, now we're going to start talking about multi-step solving inequalities. So remember I talk about blinders. So first thing you want to do is put on your blinders. For me, I have a actual literal blinder that I'm going to ignore the rest of the equation. And if there is like a plus in there and stuff, I would also ignore that and I would only focus on my distributive property area. Okay, so put on your blinders. Then you want to think of this as, hey, this is a length and a width, right? So right now the way it's written as a length times width. So if I could just find the area of this rectangle, then I could write it as an area and I don't need to write it as a length times width. And it would get rid of all of my parentheses that are there, right? And that's what's stopping us from moving on. So to get rid of our parentheses and treat it, we treat it like a rectangle. And we're going to set up the rectangle. And we're looking for the area of this rectangle. We're going to pretend it's a very nice rectangle. Okay, so the length is 2. So that's this side of the rectangle is 2. Okay, and then the width is this whole thing, which is 3x and minus 5. Okay, notice how I kind of separated them? That's because I'm going to treat them as separate boxes. Okay, and in fact, I'm going to even change that minus 5 to be a different color. This here width is 3x. And then let's just go ahead and draw over this guy. Minus 5. Well, it's kind of hard to draw over him with the mouse. Okay, that's the green. Negative 5 is this length here. Okay, so when we are looking for the area of the box, we're looking at, first of all, this far left box. Its dimensions is 2 by 3x. So to find that area, we would do 2 times 3x. Right? Because this length times width will give us our area. And that is a 6x. Okay, so that's the area of the first box. Then we're going to look at the next box, which has a length of that minus 5. What is this length here, by the way, for the box? Okay, and the answer is it's also 2, right? Because it's a rectangle. So it's going to have that same length all throughout, okay? So the area of that box is 2 times a negative 5, right? And so the area of that second box is going to be a negative 10. So what was here written as length times width, we could write it as an area of 6x minus 10. Okay, and we can write it as that area because it is the result of length times width. Okay, so this area basically replaces that whole thing, that 2 times 3x minus 5. All of that is replaced by 6x minus 10. Okay, so it's gone because this is 6x minus 10 is the area way to write it. It's distributed already, right? So this is written in factored form. This is in multiplied form, okay, where it's already an area and there's no parentheses. Okay, once we got rid of our parentheses, then we could go ahead and pull out our blinders, okay? Now we can look at this and be like, okay, here's the rest of the problem, right? We have 6x minus 10 is greater than 2x plus 6, okay? So I'm just going to take all of these guys and group them together. We're going to kind of shrink them, keep it on the side. Remember how we got to 6x minus 10. But now we're going to solve this. And we have variables on both sides. Okay, and we want to combine them. What would you do to combine them? Put it in the chat. Okay, what would you do? Okay, so we have our 6x minus 10. Okay, well, you guys are being all shy today. Okay, so what would you do first? And hopefully, maybe it's just lagging on your guys' side, but we want to do minus a 2x from both sides because they are on different sides, right? And it's not an equal sign, but it's different sides of where we are comparing. Okay, that's why we're using inverse operations, and that's how we get 4x minus 10, because that minus 10 didn't go anywhere, so still there, is greater than 2x minus 2 is 0. 0 plus 6 is 6. Okay. And then what would we do next? Oh, let's do the inverse operation of this minus 10. And the inverse operation of minus 10 is plus 10. So plus 10 on that side of the inequality and plus 10 on that side. That leaves us with 4x, because 4x minus 0, that's gone to 0. Whoops, that was major. Okay. Okay, so 4x is going to end up being greater than 16. So again, isolate your x, divide by 4, right? And we end up with x is greater than a positive 4. Okay, so, and again, is it part of the solution or not, right? And we're like, oh, wait a second, let's check it. Is 4 greater than 4? And 4 is not greater than 4. So it is not, right? So remember, I draw my not. I'm not even going to write not true. I'm just going to write not to save time. And then we can graph it, right? My line here. This is going to be my 4. This is going to be my 5. This is going to be my 6. Just kidding. It's smaller, so it's a 3. All right. Okay. So we're going to take this. It's not part of the solution. So we clone this guy. It's going to be our open circle on 4. This 4 is not part of our solution. And it is greater than. X is greater than. So we are going to go to the right. Okay. So it's kind of like a lot of steps. But if you know how to do your inverse operations, if you know how to isolate your variable, you just take it one step at a time. Put on, figuratively speaking, blinders, okay? Meaning just kind of ignore what else is there. Focus on one part and then just go through it one step at a time. And that's kind of why you need to have a paper. And inequalities is also why when you're doing equations, we didn't want you to just figure it out in your head, right? Because there's so many answers that would have made this sentence true. You can't just plug in X values and try and guess and check, because you're not necessarily going to find that middle number, that limit, that barrier between solutions and not solutions. Okay, so you got to use your inverse operations and practice. Alrighty, bye.